MPLS, multi-protocol label switching. Multi-protocol. See, not one protocol, multi-protocol. Now, how many routing protocols do you know? Okay. And in the EGP, you know BGP. You started BGP. You also know to an extent BGP. We are going to see BGP later. Now, with all this protocol, MPLS can work. It can work with RIP, EIGRP, OSPF, BGP. This multi-protocol label switching MPLS can work with all this, any of this. There is no limitation saying this will work only with OSPF. That's why the name multi is given. You see, whatever the layer 2 technology you may have Ethernet, you may have something else like PPP or HTLC. This protocol can work. Not only with multiple routing protocol, it can also work with multiple layer 2 protocols. That's why the name multi-protocol is given. And you see, a label switching. What is this? Usually, routing is done based on the destination IP address of the packet. Do you agree or not? So every packet will come with source destination IP address. Router looks for the destination IP address. When it finds one destination IP address, using which the routes will be identified in the routing table and packet will be routed, isn't it? Now, question is, where is this routing protocol, or where is this destination IP address? Of what? Correct. So, in each packet, you have IP address. To know the IP address means destination IP address. Now the router is going to read. Router is going to read the complete layer 3 header of every single incoming packet. Do you understand this? No, what I'm saying is not that simple. I repeat. Every single packet has got layer 3 network layer IP header. If I get 1 million packet, that router should open that 1 million packet one by one to know the destination IP address, isn't it? See, that 1 million packet may go to the same destination, even though it goes to the same destination. How router will know that it goes to the same destination without opening that layer 3 header? Not possible. It has to open every single packets layer 2 and then layer 3. In that layer 3, it will find the destination IP address. And then it goes to the routing table, finds the path, exit interface, and send it out. You said correct. That is what expected by a router to do. What is there here? Something big. There is definitely something big is there. What is it? No, I'm not. I did not get into MPLS at all. I first of all want you to understand the normal routing. And then only if you listen to MPLS, you will understand how important is MPLS. So every time when you go through a toll, they put a gate. For every vehicle, they put one gate. They make you stop. And we used to pay cash earlier. Earlier, no Paytm, no Google Pay, nothing. Used to give cash. And then they used to give change. For every vehicle, they need to put a gate. They need to type something. There is no scanner on those days. They used to see through the camera your registration number and they will type and they will generate a ticket. 100 rupees toll fees. And you will give 1000 rupees, they will give you 900 rupees change. And then they have to open the gate. And then you will move. Again, they need to put the gate and again they will start the same process. But now they want to put with global positioning system, GPS. You just pass through the toll, automatically money will be taken. So no need of putting gate, no need of scanning, nothing needed. Zoom into the area, you will be charged. No gate is needed. And when you zoom, if you don't have money, it is going to go in minus and it will somehow, the banker will come and catch it. Now, that is also routing. This is also routing. Isn't it? Earlier also, toll was there. Now also toll is there. What is the difference? Now you zoom. Earlier you cannot zoom. You need to stay in the queue, give the money, they take the money, they generate a ticket with the registration number, your car registration number. You collect the ticket, then gate opens and you go. And you said, that is the job of the toll guy. That's what you said 10 years back. That's the job of a toll guy. That is expected from a toll guy to do. But now if I say that, you won't agree. Now if I say that, they will put a gate, you give money, they will count 900 rupees, give you back after taking 1000 rupees from you. And then they will open the gate. You are not happy now. But earlier, you were accepting that, isn't it? Earlier, you were ready to wait in the queue because you did not know that there is an option, better option. On those days, you did not know that there is a better option. But today, you want to accept that old option. Today, you want something fast because you already exposed to fast track and now GPS. Now you are not ready to accept the old routing, isn't it? That is what MPLS is. MPLS is GPS. MPLS is fast track. Normal routing is the old toll system. Now we cannot say old routing is good. That is what I expected. No, we need something better. MPLS makes routing faster and better. How? It's exactly the same like what fast track does. Nothing new. If you know a fast track, you know MPLS. When they scan your fast track sticker, when they scan your fast track sticker, what all comes, you know? Your phone number, your car make, your car color, your car capacity, your car registration number, your car owner name. All this comes just one scanning only. But earlier, to know this, they need to see through the camera and they need to type the registration number manually to generate one ticket. Now one QR code, or whatever the code is called as, that code they need to scan and all the infos come in. And the bill even comes to your SMS now. Earlier they used to give a physical copy. See, it has reduced your time in waiting in that all. It has increased the speed, isn't it? It has increased the speed. True or false? True. It has increased the speed. We cannot deny that. It has increased the speed. Same thing. Earlier you were going through the entire field of layer 3 header to know only one thing. What it is? The destination IP address. But now you don't need to go through the entire header. You will have one fast tag called label. You will have one fast tag called what? Label. And when a router read that small label, it will know to which network, to which destination the packet needs to go. And where is this label? This label is definitely not in layer 3 header. Why? Layer 3 header is too big. And to just know this one field info called destination IP address, we used to read all the field earlier. Only then you will know this one information. To know that one information, without reading the entire header, a router cannot know that one single small info. To know that one small info, routers used to read all these fields. But now, the label is kept before this header. If this is layer 3 header, IP, it is kept below and above layer 2. It is kept below layer 3 and above layer 2. So that before reading this layer, the router will know by looking into the label, let's say label number 40. When the router read 40, it knows that this belongs to 8.8.8.8. It knows the destination. Very, very good assumption. Just 32 bits only, not byte. It is bit only. You see, here the destination IP address itself is 32 bit. And source IP address is another 32 bit. And this field, protocol field, QoS field, fragment bit, protocol field, and then what? There are many fields. Optional field, TTL field, lot of fields. Thousands of bits you need to read. But here only 32 bit you read. In that you will find one label which is only 20 bit. How many? 20 bit. The label is only 22 bit out of 32 bit. By reading just 32 bit, you will come to know one label. And when you read the label, you know the meaning of the label. You know the destination of that packet. Label number 40. 40 is given to, let's say, 8.8.8.8. Every router knows that this label means this. For every network, there will be one label. Like you have that fast track tag. For every vehicle, there is one tag. By reading the tag, every toll knows that this is the owner of that car. Everyone will know that same thing, isn't it? If I scan the tag in Bangalore and also in Trivandrum, the information that they are going to retrieve from my fast tag is same. It's going to say this is Bolero, Mahindra, silver color, and the owner is this guy, Jay, and this is of this many seaters. This is from this registration, this state. Everything it will show. Yeah, correct. Here also the same story. When MPLS is enabled, a label will be initially assigned to every single network. A unique label will be assigned to every single route in the routing table and maintained in the MPLS label forwarding information base. You can see this by typing the command show MPLS forwarding table. I'll show you when I do the lab. So what we have seen now is why MPLS. MPLS is to fasten the communication. Is your traffic today is fast, no? Because of fast tag, you don't wait much time waiting long in the queue in the tolls nowadays. In another word, I should say the transport has become faster. Likewise, you don't waste time in reading all these fields which are really not necessary for a router to take one decision where via which interface to forward out. To know which exit interface I should forward, it need not to read all this info. It's a waste of time. You need this fast tag, MPLS. So if you put this fast tag in every packet, MPLS header, the receiving router, by reading the label, it will know the destination and it will quickly send the packet out. Is this part clear? I'm going to tell you the other part, which is even before MPLS exists, called CEF. CEF, Cisco Express Forwarding. No. Yeah, this exists today with MPLS, and also it exists even before MPLS to support, to make routing faster. You got it? Before MPLS itself, our routing is faster only. Then why MPLS? With MPLS, it is much more faster. No, I'll tell you. Wait, I'm coming there. What is CACF? What is Cisco Express Forwarding? See, express forwarding, Cisco express forwarding. I'll explain now. But I want to tell you that even before MPLS, the Ceph is contributing in fast routing. So that when you add MPLS to it, it is much more faster. Now, before breaking that mystery that you are looking for about Ceph, I would like to say something more. Then I'll take you to that mystery Ceph. I know you are thinking only about Ceph. What is this Ceph is about? Is it adding header? What it is doing? How it is making faster? But before that, I would like to tell you something which is very important. Otherwise, later if I tell you, will forget. Now is the time I should tell you everything about Ceph. You see, without Ceph, no MPLS. Very good question you asked. It's the same question like 12 years before. Someone asked me in Cisco itself when I was teaching this MPLS. They were asking like, if Cisco Express forwarding is important to have MPLS, then how the other vendors are having MPLS? That was a good question. The Cisco employees asked me, and you also asked me. Many people have asked me whenever I teach this topic. Actually speaking, Ceph is Cisco's name given to Fib. Every vendor calls it as Fib. Exactly. Cisco calls it as Ceph. Now, what is this Fib then? You said correctly, forward information base. But what it is? See, the name itself has got. It's an information base which is used for routing, forwarding. Now, then why do we have RIB? Routing information base. That's what. Why do we need RIB when you have FIB? You see, a RIB is what your routing table is. Yeah? But where is your routing table? Layer 3 engine. Who runs this layer 3 algorithm? Sorry. Yeah. Now, for RIB, what is important is layer 3 algorithm, layer 3 engine, layer 3 buffer. So you need to go to a special CPU of the router in order to get routed, isn't it? What they did, when I say fib, it means Ceph, okay? When I say Ceph, it means fib only, okay? Now, even before MPLS, what they did is, why are we going every time to layer 3? Why are we going every time to layer 3? Copy that layer 3 routing information into layer 2 table so that you no need to go every time to layer 3 engine. You understand? The routing information base is duplicated. It is copied and saved in fib, which is in layer 2. CIF is where? Layer 2, Roman number 2, layer 2. So that when a packet arrives, if there is no MPLS, when the packet arrives, it will read the entire layer 3 header to know one information called destination IP. After learning the destination IP, there is no need to go to RIB because the information is right there in layer 2 itself, so it can send the packet out. It can forward the packet out with the information which it received in layer 2 itself. What is FIB? What does it have? What it has got? That's what I said. When you know the destination of a packet, packet is coming into the router now, isn't it? Packet is coming into the router. Router is reading the layer 3 header. Layer 3 header of the packet, not the layer 3 engine, not the rib. It is not reading rib. It is reading the layer 3 header of the packet, incoming packet. In that, it knows the destination. After knowing the destination, usually before SEF, what it used to do is it used to go through the rib and then it will give the command to layer 2 and then the packet will go out. After SEF, because the rib information is stored in fib, which is in layer 2, soon after you, of course, in the motherboard, it's a different section. So now, after knowing the destination of the incoming packet, it checks the layer 2 table. Layer 2 table itself says, go out like this way. Get routed in this interface. You understand? So there is no need to go to the other portion of the motherboard. So fib or ceph makes the routing faster. Do you agree with this? Now, when these two things together added, your routing is going to be much more faster. See, in ceph, you still need to read the layer 3 header, isn't it? Now, after MPLS, that label number will be added to ceph itself. 8.8.8.8 So when a packet comes with label 40, the layer 2 table itself knows what 40 means. 8888, then send via Ethernet 0/0. Packet is sent out. No. Automatically MPLS will add it. That is why I said without Ceph, there is no MPLS. Why? MPLS is going to add label to the Ceph table only. Of course. The sending router will put the label and send. When the receiving router will compare the label in the Ceph table, then it knows the network and it knows the exit interface. Then why it needs to check the routing table? Why it needs to check the layer 3 header? No need. See, two things you avoided now. Reading the layer 3 header in every packet, millions of packet is avoided. And looking into the read table for every single millions of packet is avoided. This makes routing faster. Do you agree? Then it will go normal IP routing using Ceph table. No label. Ceph table is there. It's not that fast like MPLS network. A little less fast because now it needs to read what? It needs to read the layer 3 header to know the destination, isn't it? Yeah. So MPLS depends on Ceph or fib. Another vendor language, it is fib. In Cisco, you cannot disable the Ceph. Sorry, in Cisco, you can disable Ceph. That's why in Cisco, whenever you learn MPLS, you will see without Ceph, there is no MPLS. There's a point. In the other vendors, they will not tell this point. What point? Without fib, there is no MPLS. They won't say that. Why, Most of the vendors, they don't allow you to disable fib. It will be always enabled because it's good, no? It is making routing faster, no? Why you simply disable it? But Cisco has got an option to disable. So you disable. If you disable, then don't think about MPLS because MPLS adds label to the fib table only, Ceph table only. That is why you need. Fib itself is only routing table, and after you enable MPLS, then it will have label also. Yeah, always have the copy of the routing table. When you enable MPLS label also get copied for every single network. Labels are given attached to the Ceph table entries. You're right. So you cannot disable fib in the other vendors. The copy of routing table will be always there in the forwarding information base so that the forwarding can be faster. See, everyone wants the router to be appreciated. So they put the fib there. Why you unnecessarily disable it and make it worst? So they don't allow you to disable. They don't even speak about this. But in Cisco, you have an option of disabling. So we have a point. What point? You need to have Ceph enabled. By default, all Cisco routers, Ceph is enabled because every vendor wants the routing to be faster. If someone for some reason disabled it, please enable it before you enable Ceph. Is it clear, sir? Now, I've told you two things. What Ceph do, what MPLS do. MPLS also does something in layer 3. Ceph also does something with respect to layer 3. But are they same? No. Ceph does something on router. MPLS does on the packets. Why you are silent? Yes or no? MPLS is adding a layer in every packet. Ceph won't do those things. Ceph is just adding a buffer called fib or Ceph with all the routing information on the router only, not on the packet. When both join together, they can make your routing faster. Now I'm going to give you a video of basic MPLS. What I have delivered so far is the foundation and basic and important of MPLS. Now how it works. you will see in my previous class demo video, lab, and then you will come back in next class so that I can take you to the next level in MPLS. MPLS, most of the people, when they say MPLS, they really do not focus on what I am talking now. They focus on the next level which I am going to take. But they don't know that without this level, that doesn't exist. Without this, what you learn today, what they speak about MPLS doesn't exist. When they say MPLS, they mean VPN, layer 3 VPN. No, that is not layer, that is not a MPLS. This is MPLS. That is MPBGP. Along with BGP, when MPLS add together, it can provide you a layer 3 circuit. But most of the people, when they say MPLS, they mean that VPN only, MPBGP, MPLS with BGP. The actual MPLS is what you have learned today and what you are going to see in my demo video.